Today we're going to talk about 5-3, rates of change and slope. So we're getting into the part where we talked for a long time about how to graph a line using slope. So before we use slope, we kind of need a background of where did slope come from. And we're going to start with rates of change. So a rate of change is a ratio that compares a change in the dependent variable to the change in the independent variable. And then we're going to use something called rise and run to help us with slope. So rise is the difference in the y values of 2 points on a line, and run is the difference in the x values of 2 points on the line. And then we put rise and run together to get slope, which is the ratio of rise to run for any 2 points on the line. So let's start first of all with rate of change. Here's the equation we're going to be using for rate of change. Rate of change is the change in the dependent variable over the change in the independent variable. And your rates of change problems are going to look like this. Okay, it'll give you a table and tell you a situation. So the table shows the average temperature for 5 months in a certain city. Find the rate of change for each time period. During which time period did the temperature increase at the fastest rate? So the first thing you got to do is identify the dependent and independent variables. Now the month is going to be the independent variable because nothing really determines what month it is. That just comes and goes. And then the month determines the temperature that we have. So that's going to be the dependent variable. And then what we're going to do is use our little equation here to find the rates of change. So let's start with months 2 to 3. So when I'm going to do this, I want to find the change in the dependent variable. Remember, that's the change in my temperature. So that would be 56 minus 56. And I always go second minus first. So 56 minus 56 over the change in the independent variable, which is my month, 3 minus 2. So 56 minus 56 is 0. So the rate of change from month 2 to month 3 is 0. And we're going to do this for each month. So let's go now months 3 to 5. So now we have 63 minus 56 over 5 minus 3. Remember, second minus first. So 63 minus 56 is 7. 5 minus 3 is 2. So that rate of change would be 3.5 or 3.5. Now let's go months 5 to 7. So that will give me 71 minus 63 over 7 minus 5. So 71 minus 63 is 8. 7 minus 5 is 2. So the rate of change for temperature between those months is 4. And then finally, months 7 to 8. So now I have 72 minus 71 over 8 minus 7. And that gives me 1 over 1, which is just 1. So the rate of change for months 7 to 8 is just 1. Now notice, after we find the rates of change, it says during which time period did temperature increase the fastest rate. So I look at my rates of change here, I see that from months 5 to 7 it increased at a rate of 4 degrees per month. So that would be the largest increase. So I would write months 5 to 7. That would be my fastest rate of increase. And then I'd be done with that problem. So that's what you're going to do when you're given a table. It asks you to find the rates of change for each period and then to identify which one increases the fastest. Now another way that they will have you do this is using graphs. So once again, they'll give you a table and then they'll ask you to graph the data in that table. So let's do that here. We have postage costs over different years. So 1985 was 22. So let's go 1985, 22. And then 1988 was 25. right here. 1990 was 25, so it's going to be right here. 1991 was 29. And 2004 was 37. So this is 2005 over here. So 2004, 37. That's about right there. Okay, and then what we're going to do is connect these. So there we have our graph. And then what we want to do is use the graph to help us find rates of change. And this is how we do that. We're going to start here at 1985. And we want to count how much do we have to go up and how much do we have to go over between 1985 and 1988, I believe was the next one. Yep. So it looks like I went from 22 to 25, so that would be plus 3. And then I went from 85 to 88, which would also be plus 3. So my rate of change for 85 to 88 would be the change in the dependent variable, which is my cost, over the change in the independent variable, which is the year. So 3 over 3, or 1 cent per year it went up. Okay, and then let's go the next one here. From 88 to 90, we went up 0. So 88 to 90 now. The cost changed none, and the year changed by 2. So 0 over 2, which is just 0. So our rate of change for that time period would be. Now let's go for the next time period here, which was 90 to 91. So for that one, it looks like I go from 25 up to 29, so that would be plus 4, and then I went just over 1 year. So plus 4 plus 1. So the change in cost would be 4, change in year would be 1, so my rate of change there would be 4. And then finally, I'm going from 91 to 2004. So I go now from 29 up and over. So from 29 to 37, that's a change in 8. So my dependent variable changed 8. And then from 91 to 04, that's going to be 13 years. So 8/13 would be my rate of change for my last segment. And this is how I would show my work on my graph. Okay, how much do I go up? How much do I go over? Now you might ask, why do I have to do it this way? Really, it's preparing you for what we're going to do next, which is slope. Okay, so when we do this on a graph, we're going to say, how much do I go up? How much do I go over? And we put how much I go up over how much do I go over to get my rate of change. Now this one doesn't ask which one is the fastest rate of change, but if it did, it would be from 90 to 91. So next, let's talk about slope. So if when we draw a graph, all of our segments have the same rate of change, then they all have what we call the same steepness and would form a straight line. Now when we have a straight line that has a constant rate of change, okay, these first two examples we didn't have a constant rate of change, but when we have a constant rate of change, we call that slope. And we calculate slope with this equation here. You will hear me say this over and over and over again as we're talking about slope. Slope is rise over run, or change in y over change in x. Remember, y is the dependent variable, x is the independent variable. So it's the same thing that we've been doing, but now we're talking about a constant rate of change across an entire line. So we have rise over run, or change in y over change in x. So the first thing you're going to be doing when we talk about slope is they'll give you a line and they'll say, find the slope of the line. Okay? Now, what you want to do is identify 2 points on the line that you know what their coordinates are. So, for example, this coordinate is -6, 5. Okay, I picked that one because it's nice whole numbers. I wouldn't want to pick somewhere in the middle when I don't know exactly what it is. I might also pick this point here, coordinates 3, 2, again because they're whole numbers. So then I want to find the rise over the run. So how much do I have to go up and then over to get from one point to the next? So to get from this point, 3, 2, to -6, 5, 1, 2, 3. I can just count the boxes. I went up 3. Then, how much did I go over? 1, 2, 3, 4, 5, 6, 7, 8, 9 over. And I went to the left, so that's -9. So if I go for slope now, remember slope is rise over run, so my rise was 3, my run was -9. And if I reduce that, I would get 1 over -3. So my slope of that line would be -1/3. And that's how I would find slope. Now, a couple of special cases you need to know about are horizontal and vertical lines. Let's find the slope of each of these. Once again, I do rise over run. So let's start at this point. How much do I have to go up? 1, 2, 3, 4, 5, 6. So my rise would be 6. How about my run? How much do I have to go over? None. Now if you'll remember, whenever I divide by 0, I can't do it. It's undefined. So vertical lines have an undefined slope. Let's look at horizontal lines. Again, rise over run. How much do I have to go up? None. How much do I have to go over? -8 to 4, that'd be 12. Now remember, 0 divided by anything is 0. So horizontal lines always have a slope of 0. Vertical is undefined, horizontal 0. So as you can see, we have different types of slopes. We have positive slopes, negative slopes, 0 slopes, and undefined slopes. So one thing you'll be doing on your homework today is just describing slope. They'll give you a line and say which slope does it have, positive, negative, 0, or undefined. For a positive slope, the line is going up from left to right. It's like if you were climbing a mountain. Okay, positive slope going up from left to right. Negative slope is going down from left to right. Okay, so that's how you tell the difference. Positive up, negative down. Then we just talked about horizontal and vertical. Horizontal lines have a slope of 0. Vertical lines have undefined slope. Okay? So, I know that was a lot of information in a short amount of time, but that's everything from 5-3. If you need any extra examples of anything, just let me know, and we'll go over that tomorrow. I'll see you then.